We will talk about properties of electromagnetic waves, their generation, transmission, reception, required devices, detection, and also applications. Firstly, let's talk about main properties of waves. Let's explain that there is sun. You know, this is our lovely star with her sunglasses. We know that there are many explosions in the sun. Because of these explosions, sound waves are produced. And we know that sun emits light. It is so interesting, sound waves cannot reach our planet, but light can. Why? This can be explained by, that means sound waves need medium to travel, some waves do not need medium. We can classify waves according to this property in two groups. The first group is mechanical waves, and the second group, electromagnetic waves. Mechanical waves are the waves that need medium to travel. But electromagnetic waves are the waves that do not need medium to travel. In this chapter, we will talk about electromagnetic waves. We will explain them. Firstly, let's remember chapter 2, electromagnetic induction. Scientists say that if there is a conductor rod like that, when a current flows on it, changing current produces changing magnetic field. Remember that. And also changing magnetic field produces changing current. This process is called electromagnetic induction. This process lightens Maxwell, and he explained new relations. What are they? Let's talk about theory of Maxwell. Maxwell says that he is a great scientist. The first one. If there is a charged particle, whatever it is, positive or it is negative, the electric field is generated around it. Remember, for positively charged particle, electric field is directed to out, we can say, and for negatively charged particle, it is in. This is direction of electric field. This is the first one. The second one, Maxwell says that there is no magnetic unipole. He means if there is n pole, magnetic n pole, there must be s pole. There is no magnet that contains only north pole or only south pole. There is only n. This is not true. The third one, Uncle Maxwell says that if there is changing electric field, remember electromagnetic induction, it causes changing magnetic field. In fourth one, opposite of this, if there is changing magnetic field, it produces changing electric field. These four rules are theories of Maxwell about electromagnetic induction. If there are charged particles, electric field is produced around them. There is no one magnetic pole. There is magnetic dipole. So magnetic field lines are closed loops. Third one and fourth one, if there is changing electric field, that means there is changing magnetic field. If there is changing magnetic field, that means there is changing electric field. This is Maxwell's theory. Now let's talk about, there is an information in our book, displacement current. What is that? We will consider a capacitor. This is capacitor. And this capacitor is connected to AC source. You know AC source, alternating current, the change of the current is reversed continuously. When a capacitor is connected to AC source, electric field is generating between plates of capacitor. but this electric field varies. So remember third rule of Maxwell. Let's remember that. Uncle Maxwell says that if there is changing electric field, there will be changing magnetic field. Let's look. If there is changing electric field, there will be changing magnetic field. This is changing electric field. So changing magnetic field is produced. That means if there is changing magnetic field, remember electromagnetic induction, a current is produced between plates of capacitor. This current is called displacement current. And this is an information in our book. After that, we will explain what are the properties of electromagnetic waves. Properties of electromagnetic waves. There are 5 main properties. What are they? The first one is electromagnetic waves travel in vacuum as straight lines. They are straight lines. Where? In vacuum. And they are reflected because they are waves. They are refracted. They are interfered. And they are polarized. They travel as straight lines in vacuum. They are reflected, interfered, and polarized. This is the first one. The second one is electromagnetic waves. Look at its name, electromagnetic waves. It contains both electric and magnetic field. And electric field and magnetic fields are perpendicular to each other. When we draw electromagnetic waves, this is electric field and this is magnetic field. And the angle between them is 90 degrees. You can consider this is y-axis and this is z-axis. They are perpendicular to each other and they are in phase. We can write perpendicular to B. And they are in phase. This is the second one. The third one, electromagnetic waves are transverse waves. What does it mean? We know that transverse waves are the waves which oscillation is perpendicular to the direction of propagation. For example, let's assume this is direction of propagation. This is direction of electric field and this is direction of magnetic field. They are both perpendicular to each other and they are perpendicular to the direction of propagation. According to this information, we can say that electromagnetic waves are transverse waves, and this is the third one. The fourth one is the speed of electromagnetic waves. What are their speed? Speed of electromagnetic waves is equal to speed of light. Where? In vacuum. Their speed is smaller than speed of light when they travel in a medium, for example, in air or in water. And the fifth one is, this is the last property. We know that electromagnetic waves contains both electric and magnetic field. That means energy is distributed between them, equally distributed between them. If there is energy, this is energy of electromagnetic waves, electric field contains half of this energy and magnetic field contains half of the energy. These are the properties of waves. Let's remember them. First one, sorry, black one. They are straight lines. The second one, they contains both electric and magnetic field. They are perpendicular to each other. The third one, they are transverse waves. The fourth one, yes, third one is transverse waves, and the fourth one is the speed of them equals speed of light in vacuum. In medium, their speed decreases if they travel in medium. And the last one is energy is distributed between electric and magnetic field equally. Now, yes, no properties, but how can we produce these sweet waves? Now we will explain generation of electromagnetic waves. Generation of electromagnetic waves. We can explain generation of electromagnetic waves in 4 steps. First one, second one, third one, and fourth one. Let's explain them. In order to generate an electromagnetic wave, we need an antenna, like that. And we need an AC source which is connected to antenna. When AC source is connected to antenna, current starts to flow and oscillates. When current starts to flow, the positive and negative charge oscillates. Firstly, we assume that positive charge moves up and negative charge moves down. Then we know that direction of electric field starts or begin on positive one and terminates on negative one. So we can draw direction of electric field from upper one to the lower one, from positive to negative. This is electric field. So how can we indicate direction of magnetic field? As you see, negative charge moves down. That means the current will be directed to up, opposite to minus charge. Then we can use right-hand rule. If the current is up, that means magnetic field will be into page, right? So we can say direction of magnetic field is into page. Then, in second part, AC source, the positive charge reaches end and negative charge reaches end too. At that time, they stop instantly. Direction of electric field from upper end to the lower one. And direction of magnetic field is directed into page. After that, they stop, then start to move again. So in third part, we can draw their direction. Now positive charge will move down and negative charge will move up. At that time, new field is produced. This is the first one. This is electric field, and this is magnetic field. Then the new wave is produced. Still direction of electric field from upper to the lower one, because still upper side is positive and lower side is negative. But direction of the minus charge, negative charge is reversed. Then we can indicate direction of current to down. According to right-hand rule, current down, that means it will direct it to out of the page, yes. This is magnetic field. But still, the loop is not completed. And then, hands of antenna. When they reach to the initial position, the current reverses. Now negative charge will move up and positive charge will move down. At that time, this is our initial wave. This is magnetic field, initial one. Then this is positive, the direction of electric field reverses. Will be like that. Still, direction of current is directed to that direction, and it is like that. Now a bubble is completed. Now we have a lovely electromagnetic wave that propagates in medium like a beam. Direction of electric field, as you see, direction of electric field at this side, and direction of magnetic field into page, here, out of the page. This process continuously repeated. So electromagnetic waves are produced.